Thank you very much. So I'd just like to introduce myself and tell you a little bit about myself. So I'm Simon Player, Director of Development for Data Platforms and Track Care. For me, this is a long-standing position with Track Care and a new position working with the Data Platforms team. I have a background in computing and information systems, and I'm a long-time consumer of both InterSystems technology and all things technical. Industries I've worked in include healthcare, oil and gas, library systems, and reinsurance. This has been a mix of both software product companies and in-house development organizations. So I think I feel close to you in whatever you're trying to do with our technology. This has given me the opportunity to live and work in different countries and different cities. From various parts of the United Kingdom to Hong Kong, South Korea, and for the past few years in Australia. To borrow a phrase from a book, Anti-Fragile by Nassim Taleb, I think I have more than some skin in the game, I have some soul in the game. And for me, one of the many strengths of InterSystems Data Platform is that it supports that longevity. So while applications can adapt and development methodologies change, the data platform is there to continue to support those solutions as they evolve. And to borrow another phrase from a technology summit in Sydney, a digital innovation and disruptive technology, it's easy to predict the future. What's hard is getting people to believe you. So thank you, and it'll be a pleasure to work with you.
Thank you, Simon. はい、サイモンさんありがとうございました。開発方法の変わってもデータプラットフォームは、不変の力を保つということでございました。それでは、次にですね、の演者をご紹介したいと思います。データプラットフォームの開発のプロダクトディレクターでございます。ビル・マッコーミックでございます。Bill, please.
So welcome and thank you. I'm Bill McCormick. I'm the Director of Product Management for the Data Platform. For those of you who aren't aware, when we talk about the data platform, we tend to be talking about the core building block behind everything that we provide in terms of technology. So we're talking about Cache, Ensemble, DeepSea, I know. All the technology that drives your solution, whether it's a partner solution, whether it's track care, whether it's health share. Okay? Terry's done a fantastic job of explaining a little bit behind the development philosophy at InterSystems. When we talked earlier, he had the slide about Iris and about interoperability, reliability, intuitive and simplistic design, and scalable. I'm going to take just a few minutes to expound on that, and then we're going to do a little bit of a deep dive into what we've been working on, what are the market factors driving our development, and then a little bit of detail about what we're doing within development to enable solutions that address those market pressures. So Terry spoke this morning about the requirement to be scalable, to be an intuitive system. Within the core data platform, though, we have a few other extensions to that, to those concepts. The most important one that I want to get across to people is that performance is the most critical responsibility we have. Our systems have to be massively scalable. We cannot go backwards on performance. Every version that we release must be faster than the previous version. Okay? Second core principle, backward compatibility. We strive to the utmost capability we have to provide a solution that retains backward compatibility as we move technology forward. We want to help you bring your solution along, and we want to enable new capabilities within the platform while still allowing your existing code to operate without having to be changed. The third critical concept, and Steve touched on this briefly, but I want to extend it a little, no downtime. No downtime is more than just saying that your system doesn't crash. No downtime means that I can update a system. I can make modifications to an existing system and activate those changes, preferably by not having to take the system down and or kick people offline. Those are key concepts that drive what we think about when we start writing code in the data platform. Now I'm going to just take you briefly through a quick summary of some of the things that we've changed recently in the product that you may or may not be aware of. We've been highly focused on SQL performance. For the last 18 months, this has been a critical project within our development organization to improve the throughput of our SQL engine. We want to handle inserts, updates, deletes, select statements as quickly as possible. We've seen great steps forward in performance for SQL. We've been focusing on removing bottlenecks. If you're familiar with our SQL and you try something in 16.2, I think you'll be genuinely pleased at the changes in performance. We'll talk a little more about some of those changes shortly in the presentation. Another key feature related to SQL that we've added to the technology is something we call frozen plans. Again, for those of you who are familiar with our technology, this is the notion that we can take some existing SQL code, a statement, and we can, today, if you did an update, when you upgrade your system, all of those plans are removed and we regenerate new ones based on the current SQL engine. Frozen plans is a concept that says I can keep the existing code in place and I can selectively decide when I'm going to start testing, verifying, and updating SQL logic to see if the performance really is better, to see if the improvements are really there, and to be able to upgrade without being concerned that changes to our engine will have a detrimental impact on your solution. Two of the key elements behind every application that you use today, every one of you in the room who's using a mobile phone or a tablet device or just consuming modern technology today, whether you know it or not, the prime building blocks for those solutions are JSON for a data transport mechanism and REST as a way of getting and retrieving data from a database system and presenting that information to you on your device. We have been focused on trying to make sure that we have world-class support for delivering those technologies to those solutions. So we've been making a lot of effort to expand on support for JSON syntaxes, tooling around handling documents, tooling around REST and RESTful APIs, and making sure that you can build world-class solutions and deliver that content to the devices you need to deliver. I just want to reemphasize a point about Cache performance. Cache version 2015.1 delivered improvements in core database speed on the level of 7 to 10 times faster capability to put data in the database and retrieve that data back out of the database. That's the sort of focus on performance that we're talking about here when we talk about increasing the capability of the engine. To come back around to that simplification story again, one of the key features we added to the product in the last few years has been support for mirroring, the notion that I can have a highly available system that has built-in failover capabilities. We've had this in the code for quite a while, but one of the key aspects that we recognized after we added this was that it had to be simpler. We had to reduce the possibility of user error resulting in a failover that doesn't achieve what it's supposed to, which is to have the system back up and running as soon as possible. So we've made a lot of effort in the recent past to improve simplifying that process and removing potential places where people could make mistakes. Another area of critical development that we've been working on is building a new IDE. There's going to be a presentation on this later today. We call this Atelier, but 2016.2 is the first version of our product where we've introduced support for Atelier. So now we get to have a conversation. What's driving development in InterSystems today in the data platform? These concepts have been around. Steve had some very nice slides that called back to some of these concepts. But the three critical factors that are driving the database platform are cloud, mobile or the modern application stack, and analytics. Okay. These are concepts that you guys should all be aware of, I hope. But the key thing here for cloud is people want systems that will run on commodity software that will be elastic, reliable, manageable, and secure. Okay? We have to enable you to be able to achieve those goals. Another key aspect of cloud that's driving development is this notion of DevOps. I'm not sure how many of you in the room have heard this phrase, but it's a completely different philosophy about how you deploy a solution in the cloud. And what it fundamentally boils down to is what they call a microservices architecture. And what that means is instead of deploying a complete application in one go and doing mammoth upgrades of all of your code at one time, you take the approach of saying, every element of my application is just a little slice, a microservice. And I can update any one of them at a time. And I can do them piecemeal, I can do them every day. And if I can do this and achieve this, the key aspect here is that I can deliver a stable, robust system quickly, easily, and update it every day. I sometimes make the joke that the people who get this DevOps philosophy, it's like joining a religion. You decide that everything in your life you have to approach this way when it comes to writing code. We need to enable people to be able to develop and deploy software in that manner. I talked back to about REST and JSON already. I just can't emphasize. If you're not writing solutions today that are leveraging JSON data capabilities and deploying and driving these interfaces through RESTful architecture, you're not building a truly modern application. Analytics play a key role in this. As we add more devices and we put more data in the database, being able to make sense of what's in that database is a critical task. I need to not only be able to understand what's there, but I need to be able to effectively analyze that data and then drive solutions that allow people to make decisions based on the ever-changing data in their database. So analytics becomes a key element for us in what we do going forward. The last concept that's important is open source. InterSystems is not contemplating the thought of going open source with any of our own technology. But what this is important to is the amount of code that's freely available in the open source market that allows you to build capabilities into your solutions is an ever-growing source of incredible innovation. We're doing you a disservice if we don't give you easy access to all of those libraries and allow you to leverage those capabilities to build the best solutions in the world. We have to give you quick and easy access to those libraries and allow you to leverage them as soon as possible in your applications. So where are we going? We're going to spend a few minutes on each of these concepts, but just in summary, we have to address issues in cloud with our product. We have to address issues with document data models. This is the core building block of JSON. We have to always be improving our SQL, enriching our analytics. This means that we might need to look at different programming languages. How does security play a role in all of this? And of course, we still need to be able to talk to every other system out there as easily and effectively as possible. So let's talk about cloud enabling the platform. We've had support for cloud operating systems for years. If you wanted to deploy on Azure, you could do this 5 years ago. If you want to deploy on AWS, 7 or 8 years ago. Okay? We've had the ability to say that you can install a cache or ensemble instance in these environments for a very long time. Okay? But that's simply not enough. We have to do something that I like to call embracing the cloud. What that means is you have to move in, you have to build the tooling around your product that allows your product and technology to be seamlessly deployed on the cloud, managed in the cloud, updated in the cloud. And we needed to add some tooling around the fringes of the data platform to enable that technology. So one of the things that we're working on in development that we're very excited about is a tool we have called IPD, which stands for Infrastructure Provisioning and Deployment. We're leveraging a technology called Terraform that allows us to quickly and easily build as many systems as we need, deployed with a pre-configured container that has a cache or ensemble instance in it. And I can just push a button and get 10 instances up. They're automatically configured, they're network aware of each other, they're ready to be operational, and I can do this in about 20 to 30 seconds. Okay? However many systems I need. Do I need 10? Do I need 20? Do I need 50? Do I need 100? It's predicated on Terraform, and the underlying building block is using Docker and Docker containers to achieve this. So you're not installing anymore. You've pre-built a container that has your application and cache and anything else you need in it, and then you're simply deploying them in the cloud. It doesn't help you very much to have 100 instances running in the cloud if you can't manage those systems, know where they are, be able to set users up on them, provision them with application data, and then monitor what's happening on those systems. So we have to add tooling around the platform as well that allows me to quickly and easily manage those systems and monitor them. The screenshot I have here is from a new monitoring API that we've built. It allows us to define what we call sensors. A sensor can be anything. We provide some out of the box. You can make your own. The example here is measuring things like CPU usage. Okay, so you get a nice UI with a dashboard that lets you monitor anything you want from any of those systems you have running in the cloud. You can define your own sensors. You can put code behind them to support them. You can define thresholds. If the CPU reaches 75%, do I want some behavior to happen? Do I want to trigger an alert? Do I want to have some sort of operation happen? So we've deployed our systems in the cloud. Now we want to start putting data in them. So we talked a little bit earlier this morning about the models and how multi-model is driving the market today. We've always had support for 3 models. We were NoSQL before NoSQL was a concept. We were multi-model before multi-model was a concept. We've always had support for storing data as objects, or looking at them relationally through a table, or looking at them as a multi-dimensional array stored in a database. We're adding a 4th model to that list, which is a JSON document. Okay? JSON, as I said, it's the core building block of solutions today. It's just something we have to have. So what are we working on? We're building a set of APIs that will allow you to have simple persistence of JSON data. I can get a JSON payload in, and instead of having to parse it and map it off to an object or a table or something I've already defined in my database, I'll just be able to persist it in the database. It's nice to be able to store it, but that's not enough. I have to be able to bring it back. So in addition to the persistence model, I need to expose that JSON data to all the different ways I can look at data in cache. So I need to expose it to SQL, I need to expose it to objects, and I need to expose it to our core language, cache object script. In addition, I should be able to take that JSON data and then project it back out of the system through a set of common APIs that allow me to talk to some of the other key technologies in the world today. The 3 we're focusing on are Java, .NET, and Node.js. I mentioned SQL performance earlier, and I want to emphasize an evolution in the way that we've been changing our SQL. So if you think about a cache process, in the beginning, the way we did a SQL query was in a given job, we started a query, it walked through your data, it collected the results and presented it to the caller. There was always going to be a maximum bandwidth that that job was able to do. It can only use 1 core because it's a single-threaded process, so it can only do so much work. I could have 20 cores on the system. Those other 19 cores would be ignored because it's a single-threaded process. So one of the key changes we made to address SQL performance was adding the notion of what we called parallel queries. The notion that I can take a job, split it across a set of jobs, hopefully use all the cores available to me on the system to get maximum throughput from a given system. We've been working on this very hard. We've had limited support for it for a year or 2. In the current version of the product, we have much larger support for this, for more types of queries and more ways to use it. But the next evolution in that technology that's logical, and this plays back to my conversation about cloud again, is if I can split a query across any number of jobs on one box, why can't I split a query across any number of jobs running across any number of instances running on commodity hardware to satisfy my queries? Go from single-threaded, multi-threaded, multi-server. So the next evolution for our SQL is the ability to distribute queries across multiple systems. For those sorts of queries, there's some limitations. I'm not going to go into all of them today right now. If you have questions, you can come find me. But the ability to spread that data across all those systems has to be there. And then once that data is spread, there are restrictions on how we can go about collecting it and bringing it back still. Another key aspect of that is, how do I get the data on all those systems? Okay? If I have something running in the cloud and I have 10 instances and I decide I need 5 more, how do I provision the next 5 systems to make sure that all my data sets are there? I need some tool that allows me to quickly dump a bunch of data into a cache database and make it available. So in addition to the work we're doing on distributing queries, is working to be able to quickly and easily bulk load a database for one of these given instances that are running in the cloud. Hopefully what you're seeing is that all of these things are interconnected. All of these things have dependencies on each other to really achieve success. So now we're going to talk about analytics. I gave to Benjamin for this slide. It's nice that he's here so I can pick on him. But what this slide is trying to show you guys is our current analytics engine. We have a core data platform. We have DeepSea and its stack exposed through a native API or through REST, and the same thing for iKnow. So I get access to my structured data and my unstructured data quickly, effectively, and easily. The next logical step forward, though, is how can I enable access to that core data from other analytical offerings and allow people to leverage different types of ways of looking at the data. And the way to do that is to build some more of these connectors. So what we see here is a very quick list of some of the technology that we plan to enable for accessing a cache database to allow you to build richer analytical offerings into your applications. So we're looking at Tableau, we're looking at Spark, Wema, things like languages like PAML and R. All of these things are ways to add analytical capability to the data platform. Which leads me to languages. This comes back to a little bit about my conversation about open source. If I want to give you access to open source libraries seamlessly and effectively, it makes a lot more sense to be able to talk to those languages natively. So one of the key developments that's happening on the data platform is the notion that we can support more industry standard languages on the server, right by the VM, right next to the data. So we're looking to add support for Java and JavaScript as server-side languages, not client-side languages, but being able to talk directly from those languages to the data storage model. The effectivity of that, of course, is once I'm talking directly to the data and I'm in Java already, I can then seamlessly go talk to all of that other code that's out there that lives in the world that knows Java and these other technologies. Nobody likes to talk about security. It's not exciting. It's just a fact of life. It's something we all have to be concerned about. We have to play nice in this regard. One of the things that's driving us in development at the moment is support for encrypting data at rest, what we call data on disk. Okay? The federal government in the US has put out mandates that say you can't build your own encryption tools. You have to use standard technology for approaching these problems. So we've had pressure from customers in the US to add support for what they call FIPS. It's a standard for encryption. You use that technology to encrypt your data. And so you'll be seeing in a new version of Cache shortly that we'll be supporting FIPS as an encryption mode for encrypting your databases. One of the other key aspects of encryption always, whether it's when you talk about SSL and anything else, is you have to manage certificates. We've had a mechanism for doing SSL, and we've had support for certificates. But what we haven't done is built out all the tooling necessary to make managing those certificates easier. How do you update certificates when they're about to expire? How do you get it a system? How can I quickly update N number of systems running in the cloud with new certificates when I need to? So we need to make that easier for you to do as well. S&I support is another area of security that we're looking at. And we'll talk just briefly now about interoperability. So when I think of interoperability, I tend to start thinking about it from the perspective of Ensemble, because that's been our interface engine for a very long time. One of the key new developments that we're doing here is something we call Java Business Services. The notion behind this is the ability to write an ensemble interface where I can do all of my coding in one environment. We've had support in the product for something we called the Java Gateway. That was the ability for an ensemble interface to go out and talk to Java and come back. The problem was you had to build the plumbing to do that yourself. You had to build the adapters, you had to build the business operation and the business services to do the calling in and the calling out. What we're doing with Java Business Services is saying, just write your Java process that's doing the work, and we'll build all the plumbing around it that you need without you ever actually having to write any cache object script. Again, this plays back into that same theme. How do I get access to all of this code out there seamlessly and easily within my environment? And how do I do this if I'm working on interfaces? This is the challenge, this is the approach we're taking with Ensemble. One key aspect of that is support for Atelier. Atelier, as I mentioned already, new Eclipse-based IDE that we've added to the product. Eclipse, guess what? It's really good at Java. So being able to do all of my work in one environment is nice. The other aspect, though, is all the other stuff that people do in Ensemble, I want to be able to do in the same place as well. So all of the stuff that you can do in the Ensemble management portal, you'll find available to you to use natively within Atelier with full integration with source control. Once we're in Eclipse, there's other things we can do to help make integrations easier. So there's a list of things that people have asked for us for Ensemble. One of the key aspects of this is something called BPEL. We have our own business process language in Ensemble, but we always get asked, can we support the standard? And the reality is that that standard isn't enough for us, because that standard is limited to web services. And what we can do with Ensemble's BPL is a lot more than just web services. We're a superset of the standard. But we want to be able to support the syntax. So one of the things that you're going to find yourself able to do is from within Atelier, we'll use Eclipse plugins that give us access to BPMN editors and BPEL generators. And then we'll be able to take that code and generate the appropriate Ensemble interfaces for you. Okay? In addition, we get requests all the time for things like managed FTP and API management. API management is the notion that you can sit there as a system, an interface engine, and go do service discovery on other services that are out there available to you in the world, generate interfaces that talk to them, and allow you to do pass-through calls, where you can just pass stuff through your ESB, call off to those other systems. Not only that, you can provide a registry of your integrations and let people do the same thing to you. It's an area that we've had a lot of requests for in the past that we're just starting down the road of trying to address within Ensemble. So I want to tie this all back with a story. It's always better if you have a story. If we think about what I've talked about, cloud enabling a platform, being able to deploy, manage, run, make use of any number of systems running in the cloud. Okay. What can I do with that, especially if I adopt a DevOps model? And the best example I can give you is one from the real world. There's a company in the US called Ontario Systems. They work in finance. They work in credit collection. They build solutions for that market. They've adopted that model, DevOps, cloud deployment, that whole picture. What did they do? They made use of source control hooks to tightly integrate their development engine to source control. They then made use of build automation tools that take that code and generate containers from source. And when a new customer calls them up and says, we want to run on your platform, what do? They push a button, deploy a container, public cloud, private cloud, whatever the customer wants, and turn it on. And the customer has access to that system within seconds. And because they've adopted a DevOps model to constructing these solutions, they've taken the amount of time it takes them to develop a new solution from a matter of months or years to where they're deploying new applications within 12 to 14 weeks, start to finish. Why is that important? They work in finance in a highly regulated market by the US government. And there's always changes to the legal code around what they're allowed to do to do business. How many times can I call someone? What time can I call them? Can I call them on the weekend? There's restrictions. And the applications have to conform to the current regulatory set of laws put out by the US government. They are destroying their competitors because having adopted this model, they're able to respond to changes in the regulatory environment faster than their competitors. What happened? They're taking away business from all of their competitors because they're delivering solutions that are compliant before their competitors can make the same offering to their customers. What has it meant for us? That company's revenue from us has doubled in each of the last 3 years since they started down this road of adopting this model of how they're deploying their solution. And it all plays back to being agile and having a modern development environment that's tailored to the way people deliver systems today, that allows them to be quicker and more effective at delivering solutions to their customers. And they're leveraging all the same technological components that I'm talking about here today. Okay? And we're doing the same thing because we want to enable that for everyone. Okay? So thank you for your time. I'm going to be here until sometime the middle of the afternoon today. If you can't catch me, my colleagues over here will be happy to discuss with you any of these sorts of concepts. Thank you very much for your time.